So 6.1 starts our new quarter off. And we're going to start off with a solid review concept. A ratio is going to be a comparison of two numbers. And when it comes to notation, there are three ways to notate that you have a ratio. You can talk about x to y. You can talk about x to y with a colon, or you can talk about x to y with words. I will probably use the first two more often than anything else. Now, proportion is often used as a synonym to a ratio, but it's not. A proportion is two ratios in an equation. And once we set up those ratios, commonly known as fractions, in a proportion, then of course we can cross multiply, which officially is called the cross product property. And if you remember, if I have A over B equal to C over D, I can simplify that by doing that crisscross multiply. Now remember, you can't have any addition or subtraction tacked on outside of those fractions. You can have addition and subtraction inside the fractions, but not outside. So let's look at some common real-life examples of where we see ratios. So example 1, Betty's Bagels kept track of its sales for 1 day. The data is reflected in the table below. So we have our number sold and our types of bagels. So first one says, what is our ratio of plain bagels to sesame bagels? So plain bagels to sesame bagels, we have a ratio of 80 to 25. We always express ratios in simplest form. 80 and 25 have a common factor of 5, which reduces to 16 over 5. For every 16 plain bagels sold, 5 sesame bagels were sold. Now our second question says, what is the ratio of garlic bagels to total bagels? Well, at first glance, there is no total given in our table. But if we add up all the different kinds sold, we can find the total is 250 bagels sold. Garlic bagels, 20. 20 over 250. Easiest way to reduce when you have zeros is they cancel. So 2 out of every 25 bagels sold was a garlic bagel. Now over the course of the whole week, we're going to change units here. Betty's going to sell 2,200 bagels total. How many of them are whole grain? So we are going to set up some sort of proportion here. The key with proportions is to compare apples to apples. So I'm going to put my whole grain numbers on top, and I'm going to put my total numbers on the bottom. Having a little note like this off to the side, make sure you keep things where they're supposed to be. So in one day, whole grain, there were 45 out of that 250. So 45 out of the 250. If that's our one day, we're going to generalize that to out of a whole week. There's my total. How many of those represented whole grain? This becomes a cross multiply problem with 250x equal to 45 times 2200. Work out your multiplication and division. 99,000 divide by 250. And we find out 396 whole grain. And that's how you solve a proportion. Now I could have put the total values in the numerator and the whole grain in the denominator. Just make sure that you're consistent with what numerator values are and what denominator values are. Another common real-life application is doing any sort of scale drawing or building for landscape, architecture, engineering, video game, toy design, all of those things need to be drawn to scale because you're shrinking something from real life. So here's our table for Pizza Barn. Actual length, scale length. What's the length of the water line in his scale drawing? So we can use either of these comparisons. So we can say 16 over 4. So in this case, I'm doing actual to scale would be equal to, my actual water line is 10. The scale is what I don't know. Or I could use 25 compared to 6.25 would be equal to 10 compared to what I don't know. Either of those setups will get you the right answer. When you cross multiply and divide, you're going to find out that x is 2.5 inches. Now you could have done it the other way with scale on top and actual on the bottom. Now if he records a scale length of 5, what is the actual value of the window length? So let's go ahead and use our 16 over 4 is going to be equal to, now we don't know the actual over the scale is 5. Or my other ratio would be 25 over 6.25 is equal to the value I don't know over the value in my scale drawing. And when you cross multiply and divide for either of those, you're going to find out that x is equal to 20 feet. Now, what we have going on for C, if he measured his actual window to be 3.75 feet wide and recorded its scale measurement as 0.85 inches, is he correct? Why or why not? Well, what we have going on is a term we're going to talk more about next lesson, which is scale factor. How much I'm shrinking or blowing up my figure. And if you looked, my scale factor is either 4 over 1 or 1/4. Okay, we'll just continue with this way, doing actual to scale. 25 over 6.25 or 16 over 4 are going to make this exact same scale factor. So what's going to be true is that 4 over 1, is that the same as taking 3.75 divided by 0.85? Because we want our scale factor to be the same throughout our drawing, when we work this out, we end up with 4.4. Since those are not the same, therefore, he did something wrong. He either measured wrong or calculated his scale drawing incorrectly. Now we're going to take this ratio idea into our geometry ideas. So in simplest form, what is the ratio of length of MN to NQ? And that's pretty easy to see that it is 16 to 16, which reduces to 1 to 1. When we look at the next example, we've got NP compared to MN. And when we look at that one, we have 8 to 16, which is going to reduce to 1/2. Now C asks us to calculate the area. And if you remember, the area of a rectangle is length times width. So MNRQ, area of MNRQ is 16 times 16, which is 256. The area of NPSR is going to be 16 times 8, which is 128, I believe. Now that I have my areas calculated, I can easily transfer over and do my ratios. And the ratios are going to be 256 compared to 128. And simplified, that's 2 to 1. Now, what's the difference between C to D? It's just the order of the ratio, because that does matter. So in this case, it's 128 over 256, which is going to be 1/2. So you always have to be careful how you are comparing numbers. Now, example 4 asks us to understand that idea of simplifying, of reducing fractions, that we're taking out common values. If our angles have the ratio of 3 to 3 to 4, what's the measure of each angle? That means in this triangle that I canceled some common factor out of all of them. And so I could rewrite that 3x, or those are angles, plus 3x plus 4x is equal to 180. 10x is 180. X equals 18. It asks for the measure of each angle. So 3 times 18 is 54. 4 times 18 is 72. So my angles are 54, 54, and 72. Similar thing in B. If the length and the width have this ratio and the area is this, remember area is length times width. If I'm going to put that common factor that got canceled in, I'm going to say 3x times 5x. So 540 is equal to 15x squared. Divide both sides by 15. X squared is 36. That means x is 6, take the square root, and that means that my length is 3 times 6, which is 18, and my width is 5 times 6, which is 30. Tune in to part 2 for the last couple examples.